normally do, as I said, we normally do thanks for new and renewing members. Unfortunately, this month there are none. So for those, I see pretty much everybody has their mics muted. So thank you very much for that. And I'll do the same when we pass things over to Jeff. So as I said, Jeff and I have been working back and forth to make this happen for a little while now. Today's session is titled District Energy and Its Future in Decarbonization of the Built Environment, which is near and dear to everybody's heart around this table, that's for sure. So the session he plans to explore the concept of district energy, tracing technical advances and looking at the opportunities in today's marketplace. Jeff comes to us with a background in mechanical engineering and project management, and he's going to talk about some of the projects he's currently working on. He's LEED accredited, and I'm going to leave it there because I'm sure everything else that's in in the blurb online is going to get touched on during the talk. So, Jeff, thank you very much for joining us, and over to you.
Okay, I'll share my screen here, get things going. If you guys can confirm that it's sharing the non-speaker note. No, it isn't. Just one second then. We'll just switch that around. How's that?
Not yet. No, we're still on the
Still in the speaker notes?
speaker notes.
Sorry, it worked perfectly when we just did it this morning.
I thought you did the duplicate slides.
Yeah, one second. Let's try. How's that?
That's perfect.
Okay. All right. Sorry about that. Thanks very much, David, for the introduction. So district energy and decarbonization are the notes in the way of the slides?
Nope. All I'm
perfect.
seeing is the slide.
Perfect. Okay, so quick agenda, just kind of the lay of the land on how this presentation will go. And I would say, please interrupt me if you have questions versus waiting to the end. Obviously, questions at the end is fine, but in the midst of it is also good. And if I'm going to speak on it more, I'll just say that. So just going to dive into what is district energy. Just it sounds like a lot of the folks on the call here have somewhat of an understanding, but just a little bit of what does that mean? What does it entail? I'm going to talk a little bit about the technological advancements that we've been seeing more recently. Some of the interesting opportunities for today, and then looking at some of the case studies, not just work that I've been doing, but just work in the industry, some of the ones that are really leading the way in regards to some of the work that's happening in this sphere. So, key things of a district energy system. You have an energy center, or it could have been called a plant at some point in time. Energy center is kind of the new terminology, if you will, and it really is a location where thermal energy can be created and then potentially shared. One of the differences between a building versus a district system is that there is that potential of sharing much more broadly, and that's through a distribution network. So the secondary aspect, or the next aspect of a district system, is a distribution network. Often these are networks that are quite widespread, so serving potentially hundreds of buildings. And then, of course, the third aspect, of course, is the end user. So the actual buildings, which could be homes, offices, hospitals, all types of occupants and uses, as well as processes like laboratories, data centers, things like that. So those are kind of the three main aspects that make up a district system. When you look at the history of district systems, they have changed over the years. Early days, coal, steam, primarily a heat distribution system was the pathway. I have a next slide that really talks about the system in New York, which was kind of the first system That was kind of this more, we'll call it modern system to a certain extent. And then it started to change a little bit. They started to add heat storage. The temperature started to change, getting a little bit lower in temperature. And then as you went to the third generation, that's when there was a lot of movement that started to happen where, again, the temperatures changed again. So the steam changed to hot water. You were looking at adding new technologies into the mix to generate the energy. And then the fourth generation is more common even now, and there is a fifth generation as well that's not really on this slide. But fourth generation is really looking at quite low temperatures, so very much like hot water, not like very hot water. It includes chilled water, and it's starting to mix and add a lot of different energy generation sources to that type of system. So and I'm going to talk a little bit about the sources, but things like waste heat, renewables of a certain extent, looking at the easiest way of kind of capturing energy and then sharing it to multiple users. Um, Early implementation. So, I mentioned the system in New York, 1877. I have the picture there. It's almost like the iconic, yellow taxi cab, at least how it used to be, yellow taxi cab. And then you'd have the steam that was coming out from the ground. And, that was just, it's just part of what people almost expect in New York. And they still are operating that steam system. It's a massive steam system. They're looking at doing things to decarbonize and modernize that system as well, but it's a large undertaking, as you can imagine, in New York. Um, there is a lot of widespread adoption of district energy in Europe. A lot of it came from the energy security and affordability that happened, especially in the 70s. And there's been a lot of really interesting things that they've been doing just because of the cost of energy in Europe. And then, of course, in North America, where we've been seeing most of the district systems is on the post-secondary side of things. So, you're looking at a campus where a lot of the ownership or management of those buildings are under the same umbrella, if you will. So, we talk about the D&D bases, same kind of idea, or urban centers. So there are some, especially in downtown areas, larger cities, things like that. So why district energy? What are some of the opportunities that come with district energy? So load diversity is one of the key ones, where you have that economy of scale to optimize and also the system operation. So if you think of it, not all buildings will be peaking at the exact same time. And so you have this opportunity to serve many buildings, and essentially reduce the amount of energy that you're having to generate because those peaks do not occur. And if you are managing or owning multiple buildings, you have the potential of actually staging buildings essentially to turn on. That was one of the things we did with one of the campuses here in Ottawa, where every building had their air handlers turning on at 6 a.m. And so there was a big push of energy all at once. And if you start to stage those out, all of a sudden the load profile really can start to shift and flatten, to support just less generation required at that time. We see it a lot as future proofing as well. The way to look at this would be, when right now there is a lot of new technology that's being rolled out, especially when it comes to mechanical energy generation. By tying a bunch of buildings to a network, the probability or the potential of adding a new technology that can then serve all these buildings versus having to do a replacement or an addition in each building definitely simplifies the potential of adding new technology as it becomes more mature, or efficient. And so, we are regularly seeing new technologies coming out, heat pumps that are becoming more and more efficient, operating at better temperatures, especially for cold climate, things like that. So the possibility of having those technologies added easily to a network is very much an intriguing idea, especially if you're running at lower temperatures for the distribution. Similarly, the opportunity of having unique energy sources and then being able to share them over a larger area of space. So things, proximities to bodies of water or waste energy sources. I'll be talking about wastewater energy here shortly. But those are interesting ideas where, traditionally, if you had a building close to it, that's great. And that building can take the advantage of those unique features, site features. But if you tie them to a network, all of a sudden, a larger campus, a larger area can appreciate those same benefits in a much larger scale. From a redundancy perspective, kind of speaks to what it is, but you end up with not necessarily having to have a backup system in each building. You can really manage that at the energy centers. Obviously energy centers still have vulnerabilities, but looking at things like loops within your system so that the piping itself has some redundancy as well really helps simplify things. And then the other one that's really interesting, especially for dense areas or new developments, the potential of not having as much mechanical space in mechanical rooms or in buildings, especially when you're thinking of cooling towers on roofs. You can get rid of all of that when you're tied to a district system. And so all of a sudden your penthouses are rentable space, leasable space, patios. There's no noise anymore because all of that equipment has now disappeared from your building. So some of the technology advancements. This slide really speaks to some of the potential of energy performance as you look at different technologies and a lot of the opportunity of trying to shift energy from winter or heat demand to summer cooling demand and trying to save energy or store energy. So the potential of using heat pumps or geothermal as a form of energy storage, even with waste incineration, which is not something that we really do here in North America, at least at this point. There are projects that are looking into that, but in the European market, that is much more popular. So the potential of having like waste generation and waste heat at different periods when we need it and avoiding really a lot of energy needs, especially for us as a cold climate dominated location. GeoExchange is a popular one. This has been around for quite a while now. I personally have this system at my house here in Ottawa. And it has been a common theme for buildings, standalone buildings, but the potential of now tying it into a district system has become a lot more popular. There are many case studies and pilot projects that are happening throughout North America that are looking at this with the potential of tying it in as one of the generation sources. And there's a few techniques that we can look at with this as well. Some of the things that we've been looking at and implementing is adding solar thermal to help reduce the size of the bore field just when the climate is more cooling dominant. There's also the potential of locating these bore fields below buildings with directional drilling on angles. And then as well, the other thing that we can look at with these types of systems is the potential of actually creating a thermal battery. The Earth is already a thermal battery, but a concentrated thermal battery in certain locations. And so that there's a lot of interesting potential with GeoExchange. And I think there's as simple as the system can be, there is interesting development happening in this sphere that is looking at technologies to try and make it more efficient, because the downside of this system is that the amount of drilling that's required can have a high cost. So it's really looking at how can we reduce those costs.
So Jeff,
Yeah, go ahead.
so you're lumping GeoExchange in as sort of a subset of district energy?
A form of generation, energy generation. So
Okay, so passive generation.
yeah, GeoExchange, and then you pair it with a heat pump. So
Right.
two techniques you could it's coming up here shortly in regards to 2-pipe versus 4-pipe district systems. But yeah, basically the GeoExchange is like a low temperature system, and then you would use a heat pump to bring it up or down to whatever temperature you need for heating or cooling.
Thanks.
No worries. Similarly, this is a fairly hot topic right now, wastewater to energy systems. So this is really looking at harnessing the wastewater that we have. So one of the interesting considerations that's happening now is when we look at a development, one of the first things we look at is, are there any force mains or large sewer mains that are passing through the area that we may want to capture heat from? These projects are happening across North America. They've now moved into Europe. So this was something that actually started kind of a little bit more in North America in this case. A lot of Canadian manufacturers. And in this one, the example image here that I'm showing, it's actually using raw wastewater, passing it through a heat exchanger. There's some filters involved. And then once it goes through the heat exchanger, it's going to a hydronic heating or cooling system. So it's not using the wastewater throughout buildings by any means, but it is really capturing that heat. And so these systems can be quite cost effective to add, especially depending on the scale of what you're looking at. So really interesting propositions. A lot of the municipal wastewater treatment plants are looking at this because they have, readily available access to the wastewater, in which case they can then look at sharing that energy out. So really interesting potential with this technology. Thermal storage has become very popular. Almost every district system that's being looked at now will have some form of thermal storage. The piping network, of course, has mass and volume, but adding additional storage to a certain extent is really helpful. Depending on where it's located, it can help with peak shaving. So if there's certain things that might really accommodate or provide a financial benefit to reducing a peak day, for instance, like what we have here in Ontario, that would be something that's possible with thermal storage, reducing by an hour. You can look at charging these systems when there is rate differences between peak rates and off-peak rates. It also can help with balancing your systems out. So, here I'm showing the well system, which is in Toronto, which is a large underground storage tank. There's lots that are above ground as well. And I did include the deep lake cooling system here. Again, still part of the Enwave system in Toronto, but just looking at the potential of, essentially a large natural storage system that can be used. And then tying them all together. So these types of systems, this is a good image that kind of shows how it's all pulling together. So the potential of having a geofield, a wastewater exchange system, thermal storage, and essentially it's multiple energy generation systems tied to a network that then serves these buildings. So you're not necessarily limiting yourself to just one energy source. There's diversity in that. You're looking at, what's available on the site. Sometimes if it's more of a urban center, there might be waste energy from different types of manufacturers and industry. So those are also really interesting ideas. We're seeing a lot more of that in Europe at the moment, but definitely some here. And I have some examples at the end of the presentation that'll speak to that, especially for the one here in Ottawa. I wanted to quickly speak about some of the differences between distribution systems. So a two pipe and, ambient loop, I'm going to use that in quotations because sometimes we might change the temperature slightly from just beyond ambient. But really what it is it's looking at a two pipe system where you're running water at fairly low temperatures, quite low temperatures compared to the steam systems. And then you're looking to elevate those temperatures at the buildings. So the potential there is, because you're circulating within the district loop, very low temperatures, the ability to add in some of these technologies that are also producing very low temperatures, like geo-exchange, wastewater to energy, even trying to pull in waste energy, let's say from a data center or something like that. That is really strong potential in these low temperature systems. And then basically refining that energy at the building level. So really looking at heat pumps and things like that. The four pipe system really has other advantages and or disadvantages. You're refining more of the energy at the energy centers. So that's where, you're looking at creating hot water and chilled water. still trying to keep those temperatures reasonable so that you're not necessarily wasting a lot of energy in the distribution system. So, maintaining those temperatures are great. Um, Potential of this one is that it's a fairly conventional design. It has the ability then of also providing heating and cooling simultaneously. So in some cases, that might simplify things, especially for the buildings. The next slide really compares the two, where two pipe really good for geo exchange systems. The potential of using high density polyethylene piping is there because it's such low temperature. You definitely have less centralized equipment. More of it is pushed into the buildings, and you also have a lot less piping in the ground. But then, like I was saying, you have heat pumps in the buildings, and you have developers that have to consider, how they would connect to these buildings. The four pipe system, when you're looking at, let's say new sites and things like that, it's a lot easier for the developers. They just need to accommodate having those supplies added to their building, but they're not necessarily looking at adding big pieces of equipment like heat pumps to elevate the temperature to hot water, usable hot water, or chilled water. So much easier for a developer to tie into, a little bit easier for them to understand what that would look like to tie into a system like this. But once you go into a four pipe system, sometimes that might lead you into some specialized piping system. So maybe insulated piping, depending on your temperatures. And of course, just because you have four pipes and more centralized equipment, the overall capital cost to create a district system with four pipe has a higher cost, an upfront cost. So that's just another thing to consider. But you're kind of weighing out both sides of, you have a district system that costs more, but then the buildings cost less. The two pipe, the district system is less expensive, but then the buildings cost more. So it's this interesting consideration when you're looking at essentially the business plan of putting in a district system or maintaining and replacing a district system.
May I ask a question?
Go for it, Tom.
Yeah, I'd like to know how a district system handles those unusual spring and fall days when you've got to switch from heating to cooling in a very short period of time.
Yeah, great question. I mean, that can be a challenge because you've got a lot of mass in the distribution system, right? So if you have the two pipe system with the heat pumps in the buildings, it really isn't much different than how you would operate a building today, where your heat pump is essentially having to adjust to manage the changes through the day. Because what was it yesterday? It was cold at first, but then it got very warm very quickly, right? And so there was a significant change that was happening just purely because of the climate and these swing shoulder seasons. The four pipe system still has that potential as well, purely because it's providing heating and cooling at the same time. And so what you'll typically find is that, especially in modern day district systems, they'll be having heat pumps at the centralized level and then be supplying a bit more chilled water as well as heating water. And then it's available at the buildings so that they can accommodate that. So both still have the potential of doing that. Where there can be sometimes the most challenges, there are single pipe district systems that I didn't speak about. It's not as much in my expertise, where you're essentially adding and taking throughout the loop. Those systems are a lot more tricky to operate and manage, and during the shoulder swing seasons, that can be even challenging, even more challenging.
Thank you.
And Jeff, while we're stopped for questions, Brooke had one up on the chat that, based on your experience, is there an estimate cost per kilometer for each DES pipe system?
So there's a couple of ways that we could look at that. I don't have a cost, like a direct cost, because it really depends on the size of the piping and how many pipes you're putting in the ground. when we're doing energy master planning for a new development, so a new district system, um, one of the key philosophies that we're looking at is really adding in this infrastructure at the same time as the other infrastructure that is needed for the community. So you're having to add wastewater, storm, potable water infrastructure. These district pipes, if they're going in at the same time, your excavation costs become basically negligible because it's all occurring at the same time. So then you're just looking at the piping costs. So that really helps. If you're trying to do something that's a retrofit in an existing urban environment where these utilities already exist, I'm actually talking about it a little bit here in the next slide. Um, you know, Technologies like directional drilling is really helping with trying to avoid infrastructure. So we have some projects here where, there's a wastewater treatment plant on one side of a major highway, and the buildings that they want to connect are on the other side. And nobody wants to close the highway, right? So, how do we directionally drill underneath that highway? And we've been doing a lot of directional drilling designs within Stantec, some really big projects throughout Ontario and Eastern Canada, and it's working really, really well. And so the potential of having that so that it really avoids all the other complications that come with trying to shut down roads and other trenching and the safety hazards around that really has a lot of potential. The other thing that's really reducing costs for the distribution is changing the pipe type. So steel pipe is still popular for sure. Way back in the day, it was concrete. It moved to steel, and now we're seeing high density polyethylene piping. And some of the advantages, I kind of put it here in the slide, you've got longevity and durability, chemical, it's very resistant to chemicals, corrosion. It's lightweight, so it really helps with the installation. And then what we've also been seeing is, with steel, you would be looking at putting in elbows to make whatever adjustments you need to make in the distribution. But with the HDPE, you can actually do radius turns. So you're not necessarily, if you're turning a corner, the potential of not necessarily having elbows is there as well.
That's interesting. Thank you for that. Because obviously mine is coming from definitely a retrofit situation. You described almost 8-wing Trenton's base, because I do have Highway 2 that separates R2 an airfield and buildings. So thank you for that information.
Yeah, no worries. Yeah, sorry. I mean, it kind of the answer can be very different depending on whether it's a new site versus a retrofit site. And some of the existing district systems in some cases are in tunnels instead of direct buried, right? We're not seeing a lot of new tunnels being built these days for distribution piping. The direct buried seems to be by far the more cost-effective approach. But yeah, tying it in with the other thing too that we're looking at when it comes to master planning of existing sites is if there already needs to be changes to the underground infrastructure. So they want to do a storm system upgrade because the neighborhood is 70 years old, or the water line needs to increase. Well, that's a great time to look at, okay, let's add district lines and consider that for that area as well, so that it's all happening at once.
I have one quick follow-up just based on your polyurethane piping. Can you use the old, like say, for example, if we did have those concrete, have you seen examples of actually just reusing and repurposing those concrete tunnels that were previously for our heating plants?
Oh, absolutely. Yeah. I mean, we're using tunnels where we can. I mean, they're great. And if the tunnels are in reasonable condition, or minimal effort to maintain, they're fabulous, right? It's I think the challenge is that now for new sites, the cost to add tunnels for that maintenance capability is just so high. But if you already have tunnels, maintaining those tunnels is a great idea. And we see that on a regular basis. Almost every campus that we work on, that has tunnels, one of our objectives is to maintain those tunnels for use for distribution. The only point that I really didn't speak to here was the first one in regards to the potential from a sustainability perspective. So I think one of the things here, and this is more the call and the need within what we're trying to do and move the needle on lowering our carbon footprint, is, looking at each individual building takes a lot of time to try and decarbonize. The potential of grouping a large grouping of buildings and then changing its energy source through a district system and then decarbonizing a group of buildings at once is a really interesting concept and has been successfully done. So we're seeing campuses that didn't have district systems adding a new system and basically decarbonizing their entire campus in one go. And so it's an interesting idea. It is happening, and it just changes the focus a little bit from trying to do each building at once into grouping them into a larger purview, essentially, for decarbonization. You're seeing a lot of changes in the operations as well of these systems. So having smart operations, demand response algorithms. Some of the operating systems now have AI potential or predictive technologies. And then, of course, adding in renewable sources, which is some of the things that I was already speaking about. So we're nearing the end. Here's some fun case studies with some pictures, which is always good. This one here is the Thompson River College campus. It's a project that we've been working on. This is in British Columbia. It's a new district system, and it's tying in the majority of the buildings on the campus, and it will be a zero carbon campus. So very exciting for them. They've started construction on this project. We do a lot of energy master planning, and it's not just looking at the thermal, but it's also the electrical. And so this is a project, I can't share the location, but basically we created a heat map of the future development. We looked at energy sources. I'm not sure if you can see my mouse or not, but we're essentially highlighting, like, this is the potential for a wastewater to energy station, because there's a large wastewater main that's coming along this side of the development. Looking at creating a large loop, adding different energy center nodes for creating that energy and sharing it, and tying in the different geofields that we are anticipating that we'd like to see, as well as integrating a solar and microgrid scenario. So really looking at this holistically, trying to feed off of the opportunities that exist on a particular development and sharing that energy out. So this is a 300-acre development. This is a project that we're doing in Ann Arbor, Michigan right now, where we created through a GIS platform, which has so much data, more data than you can ever imagine, a heat map of the city. And essentially what we're doing with this project is we are reviewing areas where district geo can be implemented within the existing city. So retrofitting groupings of communities into a district system. So this is an urban environment. The downtown area is part of the scope. And so one of the things that we were looking at was creating an energy map or a heat map of energy to try and understand, okay, where is some of our peak loads? Where is there a greater need to perhaps reduce the amount of natural gas usage? And then we added in different layers, like social justice and economic justice, the wastewater system. So where does that exist? Are there wastewater mains nearby? We start looking at where land for potential geofields could be. So whether that's parking lots, parks that could be transformed for a moment of time, things like that. So really interesting concepts and ideas. So these are projects that are popping up all over North America. This is the big project in Ottawa, the ESAP project. I'm sure a lot of you have heard about it. I was involved in this project and still am involved. I've been working on it since 2014. Multiple energy centers, a lot of them interconnected. 80 buildings that are tied to it, and the potential to grow the system. And this was a modernization. So it was changing it from steam or very high temperature hot water down to low temperature systems. We were able to get the buildings that are connected to these systems to function very, very well, very efficiently, and really help manage the peaks that the energy centers were seeing. And with the energy that they're creating on the Quebec side, they're pushing for zero carbon for this system for 2030, which is really impressive. It's the amount of buildings tied to this is 21 million square feet. I had to throw in a couple of special ones. So I'm sure you guys have all heard of Copenhagen. This is the waste to energy power plant that's in Copenhagen. Big Architecture was the one that designed this. So it's, very interesting methodology of creating an energy plant. Making it into a ski hill really helps for that public engagement. So there are concepts and ideas of trying to do similar things like this in North America. We haven't quite seen it yet. But yeah, very much a bit of excitement about how we can integrate these systems into the landscape. The ZB waterfront, this is one that I didn't work on specifically, but it is really interesting. I'm sure you guys have heard about it as well here in Ottawa. And it really speaks to the potential of harnessing some of the energy nearby, right? So they're looking at, or they are harnessing energy from the river for cooling purposes, and their heating is coming from the Kruger tissue plant that's right along the river as well. And so all that energy is being used and shared so that that community is a carbon neutral community within the city here. And then this is an interesting project, last one that I'll mention. It's Sanok, which is in Vancouver. We're working on this with Creative Energy, and it is a wastewater to energy project where the wastewater connection point is the primary energy source. And this is serving 11 towers throughout the city. So this is under construction right now, but it's a fairly large development, again, using that wastewater to energy technology. So some quick conclusions. We're really seeing district energy as having flexibility to add renewables and really support that implementation to multiple buildings. We're seeing a lot of investment in district energy, more so than ever before. All the campuses are looking at it, and a lot of it is coming from the technology advancements in the generating equipment, as well as just trying to reduce and decarbonize our built environment and boost efficiency. Yeah, and then the benefit of trying to impact our communities at scale is really one of the interesting aspects of district energy. So that is it. I'll go to the thank you side, but I'm happy to move back and forth as needed.
Well, Jeff, thank you ever so much, and very interesting on all the possibilities. Are there any other questions?
Yes, Mark here. Queen's University has a large district heating system, a steam-based system, and I've sent a few proposals to David Garish about possibly directionally drilling under Lake Ontario to get a bigger geo-exchange field. There's wastewater sewer mains that go along the edge of campus. What kind of strategy would you use for a large campus where you want to electrify to reduce carbon footprint, but you've got, dozens of buildings that you have to deal with, and a cutover strategy that's obviously going to be very challenging?
Yeah, I mean, some of the things we've had a few experiences of challenging buildings, let's say. Old buildings, poor insulation, heritage buildings, for instance, like some of the downtown Ottawa buildings. one of the strategies that we've implemented is a like a high temperature heat pump. So basically a heat pump that can increase the temperature even further beyond what the district system is. So your district system is operating at a, let's say, a reasonable temperature, because not all your buildings maybe need that. And then it's those particular few that get that elevated temperature. And so you're adding an additional heat pump to try and push that a bit higher. And it's really trying to impact those peak days. Could be an electric boiler too, or even a gas boiler if you wanted to. I think that sometimes we do have to have that careful balance about, full electrification versus those few peak days that we do experience within the our cold climate, where the potential of having some gas peaking or gas backup systems is still important to consider, because to get that 1% full electrification can be a very challenging and expensive endeavor for that 1%. I didn't really address underneath the water there, but there's so much potential. Tying into water sources like lakes and rivers has its own regulatory challenges. So there's a bit of a process for doing that for sure, but it is happening. It's happening all over the place. So the potential is there.
Great, thanks. I see Paul has his hand up.
Yeah, thanks, David. And thanks, Jeff, for excellent presentation. I didn't realize the amount of district energy that was happening just in our area. That's really encouraging. But my question is more from the as the municipality is the manager of the right of way, the road right of way. How can we assist district energy projects? I don't see us necessarily as being the driver of a district energy project always, but certainly our right of ways are going to be important for people that are looking to connect different buildings.
Yeah, it's an interesting question. So one of the unique ideas that we've been seeing a little bit, we've been seeing a push for gas utilities to develop pilot projects for green energy solutions. And because they're a utility, they have the potential of crossing property right-of-ways or property boundaries with utility right-of-ways, similar to what you're talking about, municipal right-of-ways. And that it does open the opportunity up for directional drilling. If you started to look at geofields, for instance, where maybe they initiate at the road or at a parking lot that you might own, but they potentially can go below property lines. So, at very deep depths. So, that I think that there is potential there. The other thing I'd say from a municipal perspective is that when we talk about the wastewater to energy strategy, there all of a sudden becomes a conversation about, okay, well, the wastewater system management team wants to understand what is the impact on their system, right? And the last thing we want to do is disrupt them. We're trying to remove a bit of energy from their system without it changing their operations. And so there's, that's the other aspect of it. It would be, really trying to get everybody from the city within the same kind of state of mind in regards to the potential of that source, because it can be looked at as a risk. What we've been seeing and where we've implemented it is that there's been a conversation that really reduces that risk and eliminates that risk, so that those systems can move forward. But it is always a conversation when you start doing these technologies and you're tying into a system that maybe wasn't considered before as an energy source.
That's great. Thanks so much for that. And a follow-up question, if I may. Is there a specific example of a barrier that you've encountered at the municipal level?
A lot of times it's the municipal clients that are bringing us on. So that definitely helps eliminate barriers. Like I said, I think it's different groups within cities that can sometimes be, not necessarily on the same page. And then I think the only other aspect that I can think of would be when we're looking at our overall utility master planning, trying to have a plan forward in regards to, okay, well, where does the district energy lines fit within all the other utilities, and trying to establish a bit of a standard when you're looking at the areas that are developing, and considering a district system. Those are the things that, can be massaged through, but it takes time to pull those together.
I'm going to do a bit of a shameless plug here. Kingston's very proud of the fact that we have an integrated utility service, water, wastewater, hydro, and I forget.
That's
the
great.
other ones are gas. So that, in theory, should help with something like this, because everybody should be talking already. So, yeah. I guess I had maybe I had a question back to, I guess, Paul and Lauren. Is there the potential for like a wastewater heat recovery system within the existing infrastructure? Putting you on the spot.
I think so. I should put my camera back on. Yeah, I'm actually sitting in a working group right now, Jeff. I don't know if you've heard of it. It's the Mars group. And they're kind of looking at trying to figure out a roadmap for I guess developing standards and just advancing district energy. I think their focus is on geothermal, but it could be any energy source. So I've been rolling around this in my head for a while to think about where Utilities Kingston might fit in that conversation. And I'm still struggling with what our role would be. Like Paul asked, would we be the driver of a project like that, or does a development come in and we react to that developer who wants to do that? But yeah, I think the potential definitely exists. There's lots of areas in town where we have large trunk sewers where there's always flow and always heat. We did look at a project with Queens and some students looking at heat transfer with the steam system there. So lots of ideas, but we haven't actually executed anything.
Right. Well, thank you. And I see Dave Garish's hand up.
Yeah, I was wondering if you could provide examples of campuses or groups of buildings that have sort of completed this process. I hear a lot underway. You mentioned that school out in BC. But I always struggle, when people are looking for, projected costs and savings, energy use, how the end of the project looks, to find examples that are completed.
Yeah, good question. I mean, so like many energy projects, these projects can take time. I think I mentioned ESAP project. I started on it in 2013 or 2014, and it is still wrapping up. It will be complete next year. So these projects can take time, which is why it's not as easy to say, yep, that one is done. It's complete. But no, there are some campuses that have moved the needle. In the US, I can think of a few. I believe Princeton has done a lot of legwork in regards to creating a low temperature district system. The University of Toronto has implemented a very large geosystem that is now online. That finished up, I think it was just last year. So that's a very large system. But again, is it the whole campus? No, right? Not yet. Some of these campuses are very, very big, right? And so it takes time to tackle all of the buildings. TRU is a fairly small campus, and so it will be ready to go. I believe it'll be finished in 2027, somewhere around there, and then it'll be up and running. So I know I'm not giving you exact examples. The problem is that there's a whole bunch of projects that take time, and they are all in different phases. In some cases, parts are finished, but it's not the entire campus at this point.
So to that, Jeff, you said, and I've heard from others that Europe is way ahead on the implementation of this type of system. Are there examples from Europe that we could point to say,
Yeah.
here's what it costs to operate?
Yeah. I mean, well, so I mean and I should explain too, like the Zibi system in Ottawa, that is up and running. It is using the waste heat, it is using the river cooling. That's fully operational at this point as a complete new system. So that's a good local example right here. There are a few systems in Europe. We've designed some that we didn't really talk about ownership models and what that looks like, but there's a huge change that's happening with community-owned energy systems in Europe as well, where they're looking to have 51% ownership of these systems, so that there's a little bit more um, uh, essentially stake from the community in regards to tying into those systems and maintaining use of those systems. But there are systems that are developed that are using, waste energy to try and decarbonize whole areas. I visited a massive biomass plant that was serving an entire village of buildings, all from one plant, and they were using uh, basically grass clippings and wood from the side of the roads to pump this biomass plant up, and then providing energy, steam, as well as wood pellets for the whole village.
Amazing what higher energy costs will make you do.
Well, this is it. That is probably the biggest difference. We just haven't seen the same energy costs that Europe has been seeing, especially as of late. When we compare our gas prices, it's night and day.
Yeah. I had a quick sort of technical one. You talked about steam, high temperature water versus low temperature water. Is there a measure of the increased efficiency of going to low temperature systems? Because I remember when I used to work at Queens, I'd walk down the road and I'd see, middle of February, a strip of green grass, and that was obviously the steam line running under the road, and you're going, oh, okay, not efficient here.
Yeah. Yeah, I mean, the distribution losses of a steam system is quite a bit higher, right? And so uh, I think where we are seeing the big shift, it's kind of threefold. One, the operators to manage a steam plants are becoming harder and harder to find. So there's that aspect. Um, Steam just has a lot more losses in regards to the distribution system versus a low temp system. And then the third aspect I'd say is that the ability to tie these other renewable or technologies into a low temperature system is far greater than with a steam system. So that's where there's this push to try and get lower distribution networks, because it starts to pull all those different benefits together. But steam is still like, it always has been a great way of moving energy around, but there have always been losses associated with it.
Right. Any other questions? Oh, Tom.
Yes, I'd like to know how these projects get kicked off. If there is a group interested in getting involved in district energy, is there a feasibility study that's done at first? How does this all get started?
Oh, that's so funny. I now realize that I forgot to put that slide in the deck. There was like a 10-step process that kind of identifies like how you start to getting an implemented system. I can try and circulate that, but yeah, it starts off with the concept and trying to find the right um, maybe location to implement this. And you do need to start thinking too about like what does the ownership model look like? Should it be the city that operates this? Is it a joint venture between city utility? Is it private so that there's a certain business case that needs to be presented? Um, those are some of the hurdles that do need to be determined. But you also want to do a feasibility to say, okay, well, roughly what are the opportunities? Because sometimes unless you're looking at where you have opportunities within a particular area that you're looking to focus on, you may not realize that there's some really interesting opportunities in front of you that could very significantly reduce capital cost expenditures. So I would say starting off, we usually see them starting off as like an energy master plan for particular areas, or if you don't know the area yet, it's really looking at site selection and weighing out through different criteria. Okay, what are the sites that make the most sense to do a bit of a deeper dive into? And then you can start looking at the potential of energy sources and the opportunities that might exist that could be really helpful.
Thank you.
Perfect. Paul.
Yeah, thanks. Maybe one last question that your response there twigged a question in my mind. Is it fairly common for existing buildings that maybe they're blessed already with a hydronic heating system to be able to like all of a sudden come into a district energy scheme if it shows up? Or is that a barrier?
Okay, so just to clarify the question. So you have an existing building, it already is a hydronic system. Can it be tied to a district system is your question, right?
I'm sure it could be. It's just whether or not it makes economic sense to have existing buildings tie in, or if there's big barriers.
I mean, I guess there's two aspects to it. So it's kind of like if you think about the equipment, the generating equipment, you got boilers, chillers in that building. If they're near their end of their life and you're looking at doing a major capital replacement for that equipment, tying into a nearby district system may make a lot of sense at that point. You can free up space and your capital expenditure will be less. It also takes away the operations and maintenance of that equipment. There is a compatibility evaluation that needs to be done. You know, if your temperatures are way different, there might be a bit of work that's done in the buildings. We did a lot of that type of work where one of the goals was really trying to improve delta T performance in buildings, make them work with the right temperature profiles, things like that. But it's very doable, and to me, it's just like anything. If you're at the point where you're needing to replace equipment anyway because of life cycle, you start to look at, okay, well, you could do like for like, or you can consider an alternative.
Right.
I must have pushed a button because there's a lot of questions.
Yeah, Darko, I think, was next.
Hello, wonderful presentation. Just tying into what Paul was just saying, I've seen in Europe that approach to building a district heating network, shall I call it, build it and they will come. Basically, the network is laid out and the hubs for connection to the buildings are built, but buildings are left or owners are left to join exactly at some opportune time when there's a time for replacement of furnace or something. But basically, at that point, the connection point is already in front of that building or house. Do you consider this kind of approach also? And I would say maybe in Kingston, given that integrating role that Utilities Kingston have, could be a viable approach.
Yeah. So oftentimes when we're looking at a new development and an energy master plan, if we're trying to develop a business case for district energy, the one caveat that we typically would look at would be that, you know, ideally these buildings are connecting. And so what is a way to kind of support everybody picking to connect? And so in some cases, maybe that has to be, you shall connect. It's not necessarily an option. And that's a lot easier to say for a new building or a new development. When it comes to existing, it gets a little bit more complicated. And so then there may need to be financial benefits to showcase, okay, why you would want to connect. the more people you have or the more buildings you have connected, the better the economics work, right? And so it's just like anything, the scale needs to be there. If you implement a system and only one person connects, you're not going to get the return on that investment, right? So that is the delicate balance. But I think a lot of the time, what you're also seeing is that with these district systems, there is a bit of stability in regards to the energy cost that is essentially as a utility cost out to the end consumers. That might be a lot more flat or predictable versus the energy changes that are happening that can be all over the place. And they're seeing that a lot more in Europe, where energy prices jumped like crazy, but the district prices didn't necessarily change to nearly the same scale. And so all of a sudden, the benefit of tying in was much greater.
All right, I see Mark, hand up.
Yes, Framingham, Massachusetts has an innovative approach where their gas utility has been given the mandate to hook people up to a district heating system. And from what I understand, they run the water loop on a geo-exchange basis. And as furnaces age out, people have the water pipes hooked to their house, and they have their water to air or whatever type heat exchangers in the house, heat pumps. And do you see potential for that? And are there any Canadian examples?
Yeah, no, great example. That aligns exactly with what we're doing at Ann Arbor, and there's a few other projects that we're looking at, similar thing. That one is a great example of it was the utility that implemented that. So it really, the utility right of ways really helped implement that project. It is exciting to see because it is operational now. I haven't seen, well, there is a community in Ontario that is a district geo residential community that is in construction, I believe. I'm not involved in it. But there is the exact same scenario, but it's new build. It's not retrofit, right? The Framingham one is a retrofit. So they were tying into existing buildings and existing commercial spaces.
Okay. Seeing no other hands up. We had a real run there, but that's great. The discussion is essential to this, so that's awesome. If there's no other questions, we usually close out with a bit of sector news. But first off, Jeff, thank you ever so much for the very engaging discussion. Obviously, you struck a lot of talking points for everybody around the table. As I said, we had those that would be interested very much. So thank you again. And I will take offline my question about are there others at Stantec that might want to come and present to the group and share other aspects of sustainable energy. So